Greetings Dr. Yao and my fellow classmates. My name is Aaron, and today, me and my group mates Lihao, Siau Jie, Wai Xing, Chie Yang, and James from Group 39 will be presenting our findings on 5G as enabling technology for building smart port or harbour cities. In this video, we will be segmenting it to first focus on what smart ports are, followed by 5G capabilities and technologies, and how it can be applied to smart ports using user datagram protocol and device-to-device functionality. So, what are smart ports? In a nutshell, smart ports are basically C ports which are well equipped and enhanced with technologies and innovations. Smart ports are fully automated ports that all devices are connected to via Internet of Things, with technologies such as big data, RFID, and even cloud computing being readily available in order to cope with the challenges faced by previous generations of ports more efficiently. Thus, smart ports are a more efficient, effective, and secure solution, making C ports more environmentally sustainable, economically efficient, and capable of handling increased port traffic. However, in order for smart ports to showcase their full capabilities, we will require the excellent performance and efficiency of 5G. So, why do I say this, and more importantly, how does 5G work? 5G is the latest generation of wireless technology, which delivers massive levels of performance and efficiency improvements over current technology. This will allow it to empower new user experiences and connect new industries. For our video, we will be covering the three new technologies of 5G, which are millimeter waves, small cells, and massive MIMO. Millimeter waves are extremely high frequency waves that operate on the electromagnetic spectrum from 30 to 300 GHz. They are far less congested than normal broadband connections, and as such enables super fast transfers. However, there is one major drawback to this technology. Millimeter waves tend to be more susceptible to interference and can easily travel through obstacles such as buildings, trees, and typically require line of sight for transmission to work. In this regard, however, the issues faced by millimeter waves are easily solved with small cells. Small cells are tiny base stations that ensure quality of service in the network. Small cells serve to alleviate the load on macro cells, and they also augment the network capacity and provide better coverage. Thus, by placing small cells every 250 meters or so throughout a smart port, we can prevent signals from being dropped or being blocked by ships in the port, as many of these cells can form a dense network that acts like a relay team, receiving signals from other base stations and sending data to users at any location with high data rates. In fact, small cells will also play a role in the workings of the next technology. Moving on to massive MIMO. MIMO systems, which stands for multiple input, multiple output, have been used in wireless communications for a long time now. However, with the advent of 5G, MIMO becomes massive and plays an integral part in 5G deployment. Massive MIMO adds a much higher number of antennas onto a base station. This results in drastic improvements in throughput and efficiency compared to current legacy systems. As a key enabler of 5G's extremely fast data rates, massive MIMO allows for increased network capacity and improved coverage, allowing smart ports to transmit or receive a large amount of data from various equipment in smart ports such as automated guided vehicles, remote cranes, and CCTV. With that in mind, let me list out the key differences between 4G, our current network, against 5G, and why 5G is necessary to facilitate the connectivity in smart ports. First off, 5G has more capacity than 4G. 4G can support about 4,000 devices per square kilometer, whereas 5G can support around 1 million within the same area. Adding on, 5G is also a lot faster than 4G as it is able to deliver up to 20 gigabits per second peak data rates and 100 plus megabits per second average data rates, which will be 10 times faster than 4G LTE. Lastly, 5G has lower latency compared to 4G. Latency for 4G is around 30 to 30 milliseconds, whereas 5G has a latency of 1 millisecond. Having low latency indicates that delays in transmissions are small, which also reduces the queue delay in nodes as well. When the queue size decreases, traffic intensity approaches zero, indicating lower congestion rates. This allows packets to be transmitted fast enough to its destination with minimal congestion. So, how can 5G be implemented on the smart ports, and what are its applications? With the rise of technology, smart ports are now equipped with modern freight logistics technology, whereby cranes and vehicles that handle containers are robotized, or in other words, controlled by a powerful computer. For the operation of cranes, sensors and cameras are used to determine the position of containers to be transported. In this case, we will use UDP, User Datagram Protocol, for data transmission. UDP is a protocol in the transport layer, and it is primarily used for establishing low latency and loss tolerating connections between applications on the internet. It also has very low overhead and needs lesser bandwidth to support the transmission due to smaller header. It allows packets to be dropped and received in different order than they were transmitted, making it suitable for real-time applications where low latency is needed. Thus, the high throughput and low latency attributes of 5G technology can help to support real-time transmission. UDP is also suitable for cases where a large number of clients are connected and where real-time error correction is not necessary. However, it does not have built-in flow control mechanism, making it less reliable than TCP, Transmission Control Protocol, which has flow control. To overcome this problem, the Selective Repeat Automatic Repeat Request (ARQ) protocol can be adopted. In Selective Repeat ARQ, even after a frame loss, the sender continues to send a number of frames until it has emptied the window. The receiver will keep on accepting subsequent frames, replying with an ACK acknowledgement containing the sequence number of missing frames. Sender will resend the lost or rejected frames based on the sequence number provided by the ACKs. Retransmission only takes place for lost or rejected frames. This approach allows tracking of packet loss and automatic requests for retransmission of lost packets. By using Selective Repeat ARQ protocol, time taken for retransmission and delays in the ARQ-enabled link can be reduced. It also guarantees the quality of service provided by UDP in supporting real-time transmissions. Next, moving on to device-to-device communication, which can be defined as a direct communication between two devices without the need to traverse to a base station. With the implementation of 5G in device-to-device communication, this mode of communication has become more reliable as there is now a huge improvement in the link's throughput due to the closer proximity of devices with better conditions. Furthermore, it allows for higher data transmission rates between devices, which reduces the overall time taken for these devices to process data. It also enables new services and applications, such as vehicle-to-vehicle communication, which can be implemented for automated guided vehicles, or AGV for short, in smart ports. Automated guided vehicles are automobiles that are essential in smart ports, as it is used as the main transportation of cargo, such as containers and other heavy loads. Vehicle-to-vehicle communication is an extension of D2D application, whereby automobiles can send messages to each other with information of what they are doing. This information normally includes their speed, location, direction of travel, braking, and so on. This information can be used to help automated guided vehicles, or AGV, reach their destination while avoiding any accident or collision. For example, one of the AGVs is about to exit the intersection, whereas another AGV is about to pass through the same intersection. If both vehicles are traveling at the same time, this could cause an accident to happen. However, with V2V communication, both vehicles are able to communicate with each other, understanding their position and traveling direction, which will result in a case where one of the AGVs will stop moving and allowing the other AGV to continue along its course. You have now reached the end of our video. We hope you found it interesting and informative. You can direct any questions you have to us in the comments below. Thank you for your time.